Hi, and welcome to the Pre-Algebra Tutor. And in this section, we're going to talk about adding and subtracting expressions. So what you're going to find when you start dealing with algebra is that you're going to have a lot of terms and things added together that have variables in them. And there's certain rules that basically tell you when you're allowed to add those things together and when you aren't. And so we're going to talk about that in this section. Now, I know you know how to add numbers together. I know you know how to add fractions together. What I'm talking about here when I talk about adding expressions is things that involve variables. And basically you're going to hear your teacher talk a lot about adding like terms or collecting like terms or simplifying like terms, something with the like terms in there. And what that means is in algebra, basically you're only allowed to add or subtract things together if they look similar to one another. You can sort of think of it in the real world. If I have baseballs over in this bucket over here, and I have bananas in this bucket over here, yeah, I could dump them all on the table and I can add them all together as a collection of objects, but really, in order to truly add something together, they need to be the same type of thing. I need to have a bucket of bananas over here and some more bananas over here to be able to truly add them together and tell you how many total bananas I have. If they're different, in terms of algebra anyway, you're not allowed to add them together. And that's just because they're different objects, so think of it that way. So when I say you can add like terms together, what I'm talking about is the following. So if I'm going to have a little lecture for you on like terms, it's going to be something like this. If I have 4x and I try to add to it 6x, what I really have here, x is something. I don't know what x is, but just for a second, think about it as the number of water buffaloes. Well, here I have 4 times the number of water buffaloes, and here I have 6 times the number of water buffaloes, but in both cases I've got water buffaloes and water buffaloes, so I can add those things together. So when I do that, I can take the number in front and add them together. So 4 plus 6 is 10. Now, I'm still talking about water buffaloes, so I still need to keep the x along for the ride. The x doesn't go away, it's just that here I have 4 buckets of cotton, and here I have 6 more buckets of cotton, so I'm basically adding them together for 10 buckets of cotton. But these are what we call like terms. So another example would be, let's say, 8y plus, I'm adding to it, let's say negative 2y. Well, see, this term and this term both have a y. They look exactly the same, just the number in front is different. So I can add them together. 8 plus negative 2 is 6, but I still have to keep that y along for the ride because we're still talking about, whatever it is y represents. So in each case, this is like terms because the x looks the same. These are like terms because the y's look exactly the same. But if I had 7a squared and I add to that 2a squared, you see, here's the variable. It's squared, but over here I've got the same variable squared, so they're like terms. So I can add 7 plus 2 and give me 9a squared. As long as the variable looks exactly the same in both of my little terms here, I can collect these guys and add up the numbers and carry along my little variable. And it gets even more complicated if you wanted to have like a squared times b plus 2 times a squared b. These are also like terms because I have a squared b. I have a squared b. So I can add 2 plus the 1, giving me 3 times a squared b. All right. One final example just to show you how crazy this can get. What if I had 10 times x squared times y squared times z squared plus 3 times x squared times y squared times z squared. See, this term here, as far as the variables go, I have x squared, y squared, z squared. Okay, over here I have the same thing, x squared, y squared, z squared. So because they're exactly the same, letter for letter, exponent for exponent, I can add 10 plus 3, giving me 13. 13 what? 13 collections of whatever this is, x squared, y squared, z squared. So all of these are just examples, real world, everyday examples of what we call like terms. Let's go talk about some examples of when things are not like terms. Not like terms. And you'll immediately see the difference. What if we have 3x plus 2y? You can't do anything with that because here I have, 3, cars, and here I'm trying to add to it 2 horses. Well, yeah, they're both objects, but they're not the same kind of thing, so I can't really add them. So if I had put this in a computer or something, the computer is going to spit out 3x plus 2y because you cannot add this any further. So this is totally simplified already. You can't add them anymore. Even though you might think you can add the numbers together, you cannot. So drill that in your head. You can only add those numbers together when they're in front of variables like that if the variables totally match one another. Every letter has to match, every exponent has to match. It has to look identical. Then and only then can you add those numbers and carry along the guys here. So these don't match at all, so we can't do that. If we had 6a plus 2y, we can't add these together because this variable is different than this one. So we just leave it like that. You would just leave it alone. You don't do anything more with it. 3a squared plus 2a. Now a lot of students will say, well, these are the same. I can add them. But they're not the same. Here I have a squareds. Here I have a's. You really need to start thinking about them as different things. Even though this is a times a, and this is just a, from a point of view of like terms, they do not match letter for letter, exponent for exponent. So the a is here, but one is squared and one is not, so you cannot add them any further. So you just leave it like that. There's nothing else you can do. One final example, 6x squared times y plus 4xy. A lot of students starting out will think that they can add these together because after all, they both have x's and y's, right? So I'll just make it 10, and then you start inventing math at that point. Do you put x squared? What do you put there after you add the 6 and the 4? Well, you can't do it. X squared y does not match exactly what you have here, so you cannot add them. Notice in every one of these examples, everything was identical. You know, this was identical with this. 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 It's very important to drill this in because you're going to see it. You might get it now, but then later on, a month from now, when you're working a problem, you might try to do some crazy addition that doesn't make sense. And that's because you need to really think about what I'm saying here. Like terms, they have to match exactly before you can add them together. Now, the next thing I want to show you before we get into working our problems is a very, probably the most important property in algebra that you need to learn as far as a theorem. It's called the distributive property. The distributive property. It's so important, I'm actually going to write this down. Distributive property. It's probably the most important thing, one of the most important things you need to know. And so I'm going to write it down for you like that. Now, what it basically tells you is, if you have something, I'm going to represent it by A. It could be anything. It could be a number, it could be a letter. And you open a parenthesis and you have something, B plus C on the inside here, let's say. Then the way this works is, and you'll see it in your algebra textbook, you multiply A times B, but then you add to it A times C. So you're basically taking the A and you're distributing it into this term and then into this term, getting these little terms here that you multiply, but then you add them together because you got a plus sign here. If you had a minus sign inside, it would behave just like you'd think. B minus C, let's say. It would be A times B minus B times C. So again, A times B and then A times C, but it's a negative sign, so you have a negative right there. This is something you're just going to have to remember, but let me show you really why it works. Let's think about numbers for a second. If I have 3 and I open a parenthesis and I put 4 plus 2, how would you evaluate that in terms of order of operations? You would do what I've told you to do. You would go on the inside here and you would say, okay, 4 plus 2 is 6. That's the inside of the parentheses. And then 6 times 3 is going to give me 18. That's the answer. And that is the answer. But what I'm telling you is anytime you have something sitting outside of a parentheses multiplied by something inside, when you have terms that are added together, you need to, or you can, multiply 3 times 4 and then multiply 3 times 2 and add them together. So what you would get then is you would have 3 times 4 from this multiplication plus 3 times 2. And so when you do this, 3 times 4 is 12 plus 3 times 2 is 6, and you're going to get 18. So you get the same answer in both cases, and that's just really proving to you that it works. If you evaluate it in terms of order of operations, you get the answer, but it's exactly the same thing as taking the outside number and distributing it in. It could be a letter, could be anything out here, but you have to distribute it into each term individually. The distributive property is used so much in algebra that you're probably going to forget that it's even a property after a while. You're going to use it almost in every problem because you almost always have something multiplied by something else, and if that something else is a parenthesis, then you're going to have to use that distributive property. So what we're going to do now is begin to write some problems up and just simplify them. So you may have a test problem that would say, 3x plus 6x. Simplify the expression. And you would look and say, well, this is x, this is x. They are exactly the same, so I can add. 3 plus 6 is 9. X has to stay along for the ride. That's the answer. They match, so it's easy. What if I have 3x minus 6x? They totally match. So 3 minus 6 is going to give me negative 3x. And that's the answer because x has to stay along for the ride. What if I have negative 3x minus 6x? X matches. So negative 3 minus 6 is negative 9. X stays along for the ride. And that's the answer. Now let's switch gears just a little bit to a different type of problem. Let's say it says simplify this expression. 3x plus, let's go minus 5 plus 6x. Well, the first thing you should do, like always, is simplify the inside of this parenthesis if you can. So you have negative from here, 3x plus the 6x, you can add these together because you have an x, and they exactly match. 3 plus 6 is 9, so what you're going to have is negative 5 plus 9x. You cannot do anything else with this. You cannot add 9 plus 5. A lot of students try to continue doing this addition here, but you can't because there's no x here. So this has no business being added to anything else. You can only add things together when they have the same variable out there. So we stop there, but then we notice, okay, there's a negative sign out here. There's a negative sign out here. So a negative sign, when it's sitting out in front, is like a negative 1. So we're going to distribute it into here, and then we're going to distribute it into here. So what we'll have is negative 1 times negative 5 gives us positive 5. Negative 1 times positive 9x gives us negative 9x. So we have 5 minus 9x. Now what if we change the problem up a little bit? What if we have 3x here minus 5 minus 6x, like this? How do we simplify this guy? Well, we can't really add this to this stuff yet because we've got these ugly parentheses in the way. We have to deal with the parentheses first. We cannot add these together because the terms are different, but we do have this negative sign here, which is like a negative 1 sitting out front. So what we're going to do is basically distribute it in to each of these terms. So what we'll have is 3x, and then negative 1 times 5 gives us negative 5. Negative 1 times negative 6x gives us positive 6x. Now you see, we've removed the parentheses. Now it's easy to do because we look and we say we have 3x and 6x. They match exactly in the variable. So 3x plus 6x gives us 9x. We still have the minus 5. You cannot add these. You cannot do anything else with that because these guys are not like terms because you have x in one term and no variable at all in the other term. Now what if you had 9 minus 4x minus 6? You have the same sort of thing going on. Yeah, you might want to add 9 and 6 together. A lot of students will start to do that, but you've got some bigger fish to fry first. You've got the parentheses in the way, and you've got the negative sign out front, so you have to deal with that first. So we're going to distribute it in like this. And then we're going to have everything lined out. So we'll have 9, and then negative 1 times 4x is negative 4x. Negative 1 times negative 6 is positive 6. And so now I've removed the parentheses, and everything's great. So what's 9 plus 6? That's going to give me 15. So I have 15. I have negative 4x still here, and I cannot add these at all because these guys have different terms. 15 and the negative 4x, those are not like terms because there's no x over here at all. What if I have 7x minus 4y plus 2x plus 8y? So here's a little bit more of a complicated problem because I've got x's and y's, but it's no different because I'm looking for like terms. Here I have some x's and here I have some x's. So 7 plus 2 is going to give me 9x. Here I have some y's and here I have some y's. I have negative 4y, positive 8y. So that's going to give me positive 4y. I always have to carry my variable when I do that type of subtraction. So I'm going to get 9x plus 4y. That's the right answer. So always scan. Try to find the terms that have the same exact variables in them, and then those things are things you can add together. So what if you have something a little more complicated? 7x plus 4y minus 2x plus 8y. And that's the second term. Again, a lot of students will start trying to add these things together, but you can't because you've got these parentheses wrapping everything up. You really need to try to eliminate that first, so we're going to distribute this in like this. This guy, you can really remove the parentheses right away. There's nothing out in front. There's positive 1 out in front, so you can distribute positive 1, but it's not going to do anything. So you have 7x plus 4y here. Now, negative 1 times 2x is negative 2x. Negative 1 times positive this guy is negative 8y. And now I've removed everything, put it on the same level, and now I just scan for like terms. Here I have x and x. 7 minus 2 is 5. Got to bring x along for the ride. 4y minus 8y, I'm going to have a minus 4y because I have 4 minus 8 here. So I have 5x minus 4y. Okay, what if we had 2a plus 9 minus 6a minus 10? And so we have the same sort of thing. We need to get rid of these parentheses. So this guy, I wrapped him up in these parentheses, but you don't really need them because there's nothing out in front. So 2a plus 9. Here, negative times 6a is negative 6a. Negative times negative 10 is positive 10. So we scan for like terms. We have 2a and 6a. We can add these together. These are like terms. 2 minus 6 gives us negative 4a. 9 plus 10 gives us 19. So you have negative 4a plus 19. And by the way, I'll just tell you, when you have negative 4a plus 19, you can also write this as 19 minus 4a. If you don't like seeing this leading negative here, you can just flip it over. You know, because what you're saying here is 3 plus 2 is the same thing as 2 plus 3. You can flip the order. So if I've got these things added together, I can flip the order if I prefer to look at it that way, but it's the same exact answer. So, you know, some teachers may want you to flip it around, but if they don't like seeing this negative sign up front, but personally I just leave it like that. What if you had 4a minus 6b plus negative 3a minus 2b? Okay, then what will we have there? Well, we've got the same sort of thing going on, but this is a little bit of a trick question because really, this parentheses you don't really need because there's nothing out in front, 4a minus 6b. Here, this is a positive 1, really. So I could distribute positive 1 in here, but it's going to be the same thing as just writing negative 3a minus 2b. So a lot of times you'll see these on tests to just make sure you understand what you're doing. When you have things that are added together, two terms that are added together with just a plus sign there, you can just sort of take away the parentheses and just write everything out, because if I take negative 1 and multiply it here, I'm going to get negative 3a. If I take positive 1 and multiply here, I'll get negative 3a. If I take positive 1 and multiply here, I'll get negative 2b. So it's the same thing as just taking the parentheses away. Contrast that with up here, where, you know, multiplying and everything was really important because it changed things a little bit. So look for like terms. 4a and minus 3a is going to give me positive 1a. I'll just write that as a. Negative 6b minus 2b is negative 8b. So you have a minus 8b. And that's the answer. So these are really not getting much more complicated. It's just maybe, you know, a few more things to think about. What if we have negative 2 minus 3y minus 2y plus 12? Now here we have two sets of parentheses. Each one has a negative 1 out front, so we'll have to distribute in both cases. So distributing this, negative 1 times 2 is negative 2. Negative 1 times negative 3y is plus 3y. Negative 1 times this is negative 2y. Negative 1 times this is negative 12. So we've distributed it in. Now we look for variables that we can collect like terms. We have positive 3y, negative 2y. That's going to give us y. We have negative 2, negative 12 is going to give us negative 14. So the answer to that guy is y minus 14. All right, moving right along. What if we had something a little bit more complicated looking? 1/2 x plus 1/3 y plus 1/3 x plus 1/3 y. Now the reason I want to do this problem is because it forces you to use your fractions. So what you really have here is, you look for like terms like always. You have 1/2 x and 1/3 x, so those can be added together. But what you're really going to have here is 1/2 x, let me collect them together, plus 1/3 x, and then over here you're going to have 1/3 y plus 1/3 y. So really what you're doing is you need to add these fractions together and you need to add these fractions together, is really what you're trying to do. These fractions here are really simple because it's 1/3, so the denominator is already the same. So you have 3, 1 plus 1 is 2. 2/3, you just keep y along for the ride. But this guy is a little bit trickier, and that's just because the fractions are not as pretty. So let me switch colors here a little bit. Let's see, 1/2 plus 1/3. Well, if I multiply this one, let me switch colors here a little bit. If I multiply this one by 2, and this one by, if I multiply this one by 3, and multiply this one by 2, then I'll get a common denominator of 6. So I'm just trying to find a common denominator. 1 times 3 is 3, 2 times 3 is 6, plus 1 times 2 is 2, 3 times 2 is 6. So I have a common denominator. So what I will have is 3 plus 2 is 5, common denominator sticks around as 6. So all of this stuff gives me 5, 6, x stays along for the ride, because don't forget I was adding 1/2 x plus 1/3 x, I get 5/6 x. So the final answer would be 5/6 x plus 2/3 y. 5/6 x plus 2/3 y. And really the only reason this problem is interesting is because it involves so many fractions. So again, I preach about it, but if students are not good at fractions, it's going to make algebra so much harder than it really needs to be. 2x squared plus 5 plus 4x squared minus 6. And we just do the same thing. Now notice, this is the first time we get into something that has squares in it, but we already talked about what like terms are. These guys are like terms only because we have x squared in both cases. So 2 plus 4 is 6. 6 what? 6x squared. We have to drag along whatever we're adding together. Plus 5 minus 6 is going to give us minus 1. So we have 6x squared minus 1. So when you're adding these like terms together, you have to make sure that they exactly match. Otherwise, you have no business adding them together and it's not going to work. 4y squared minus 7 minus 6y squared plus 9. How would you add those guys? Well, we have y squared and y squared. Those are like terms, so we can do that. 4 minus 6 gives us minus 2. 2 what? 2y squareds. I have to drag it along. Now we have negative 7 plus 9 is going to give me a positive 2. So we have negative 2y squared plus 2. All right, what if we have 3x squared minus negative x squared plus 7? So here we're kind of combining two things because we have this parentheses and we have this negative out front here. So we're going to distribute this negative 1 in sort of to both places. So we'll have 3x squared, and then negative times negative x squared is going to give me positive x squared. Negative times positive 7 is going to give me negative 7. Now we look for like terms, and we see right away we have 3x squared plus x squared giving me 4x squared. This minus 7 just stays for the ride. You can't add these together. You can't do anything further with any of that stuff. So the terms you look for, as we saw in the beginning of the lesson, can be really anything. They just have to match. That's really the main constraint. What if you had 5x squared minus x plus 4x squared minus 7x? So we want to add these together, and we notice that we have two giant terms and we're separated by a plus sign, but in that case the parentheses really don't do anything because you can distribute positive 1 in here, but it's going to basically just pull these out. So you can just rewrite the whole thing. 5x squared minus x plus 4x squared minus 7x. You can think of it as distributing a positive 1 in, but you're just going to get the same thing. Now we notice 5x squared and 4x squared like terms. It's going to give us 9x squareds. And then we look for other like terms. We have an x here, negative x really, and a negative 7x. So that's going to give us negative 1 plus negative 7 is going to give us negative 8. 8 what? 8 x's. So we have 9x squared minus 8x. Really just doing the same thing over and over again, just with different, a little bit more complicated problems. What if we have negative 6x squared minus 4 minus 2x squared plus 6. And so this time the parentheses really do matter because I have a negative sign here. I can distribute in. That's going to sort of change the signs on the inside here. But this guy, there's nothing out in front, so I can just kind of rewrite him. 6x squared minus 4. Negative times 2x squared is negative 2x squared. Negative times 6 is negative 6. And so I look at this and I say, okay, I have negative 6x squared. I have negative 2x squared. I'm going to add those together, giving me negative 8x squared. Here are my numbers, negative 4 plus negative 6, negative 10. So negative 8x squared minus 10. Okay, last couple of problems. What if I have x plus 2y plus 2x plus, actually let's make it a minus 3y minus 3x plus 4y. So you see, this process can be applied to anything you're adding together. And here we have 3 terms. These guys don't really matter as far as parentheses go because I have a plus sign. It's like distributing positive 1, so I can just rewrite those. X plus 2y plus 2x minus 3y. But when I get to here, I need to distribute this negative 1 in. So negative times 3x is negative 3x. Negative times 4y is negative 4y. So now I start collecting like terms. And when you have a really long expression like this, what I suggest is go with your pencil. If you have it written like this, just put a dot above a like term. So x is a like term with 2x. That's a like term with this guy. That way you're not going cross-eyed looking at it. So 1x plus 2x gives me 3x. But 3x plus negative 3x is going to give me 0x. I'm just going to keep it and hang on to it as 0x to remind myself. Now, I look for, this is a like term with this along with this. These are all like terms because they have y. So what I'm going to have is 2y minus 3y minus 4y. So let's do it one step at a time. 2y minus 3y is going to give me negative y. But I still need to do this one. So in the end, this 0 is going to drop out. Negative y minus 4y is negative 5y. And this is the answer, negative 5y. All right, the last problem of this section is going to be sort of a monster, just to kind of give you a challenge. 3x squared minus 2x plus 4 plus 2x squared plus 4x minus 6 minus 7x squared. So we want to collect those terms, and we start looking, and we say, well, these parentheses are here, but this is a positive out there, so I could distribute that 1 in, but it's not going to really do anything. So it's not going to change any signs, really, is what I mean by that. So let's rewrite it all. 3x squared minus 2x plus 4 plus 2x squared plus 4x minus 6 minus 7x squared. And then you start looking for like terms, and believe me, it's going to be easy if you just start putting dots. So x, this is a like term with this because we have x squared, and also this guy down here. So let's deal with that. 3 plus 2 is 5. 5 minus 7 is negative 2x squared. You have to stay along for the ride. Now this guy, this x term, is a like term with this one here. So negative 2 plus 4 is going to give me positive 2 to what? 2x's. And then finally, this guy is a like term with this guy. That's the only thing left. So 4 minus 6 is negative 2. So the answer is negative 2x squared plus 2x minus 2. It really boils down to writing it all out and meticulously looking for those like terms. A lot of students, if they're not comfortable, they don't have that drill down, they'll start adding these things together and getting all kinds of crazy terms. The thing that you really need to realize and remember, most importantly, is that when you add or subtract anything in algebra, if you're going to do it, they have to be like terms. So obviously numbers can be added or subtracted, but when they involve variables like 2x and 3x, they have to have the same variable there. Only then can you add those leading numbers. We call them coefficients here in pre-algebra. If they don't match, you can't do anything with them. So our final answer, notice, none of these are like terms. We can't do anything more, so we just leave it like this. So that's why we do that. So practice your problems. This is a really important section, adding these terms. Very important because doing everything with equations and everything later is going to really use these skills. So practice, make sure you understand it, work these problems. You'll build your skills. You'll do just fine in pre-algebra.